Our next speaker for this session, Mr. Amit Shrivastava, Director, Business Development, Digital Twin Solutions, Bentley Systems. He works with various organizations in the infrastructure sector to develop strategy and adoption of digital twin technology to improve efficiencies, asset reliability, integrity, and operational excellence. He has over 22 years of varied experiences in multiple capacities in sales. Please welcome him on the stage.
Good morning. So census crossed 40,000 points, so good start for the day, right? And the budget starts at 11, I complete at 11:15, so you'll be able to catch up what's happening there. So Vivek, great session, brought a lot of energy in terms of cybersecurity. What I'll focus is on digital twins, right? You heard Anne-Marie talking about digital twin, you heard digital transformation commentary around how we work across it. So when we look out around digital transformation, that's not something which is happening today. If we recollect our industry, it started in the 80s when we moved from drawing boards, we moved to workstations. 90s was the period when we started talking about automation. We started talking about process control, automations. 2000, we started about how do I integrate in engineering? How do I take control and automation, bring with engineering and working together? And now we talk about leveraging it across the complete life cycle. That's what digital twin is about and what we talk. Vivek did talk about digitization changing everything. It's changing the way we live, the way we travel, the way we work. If we talk through analysts, Gartner talks about that by 2020, we'll have about 20 billion sensors. So everything which we're working will create a lot of data, we'll be creating a lot of information, and what the process industry is looking at, how do we leverage that information? How do we really use that to create actionable item? If we can't do that, we're actually generating a data which we call it the dark data, because if you can't use data which is created to create an actionable item or make sense of it, it's of no value. You're creating historians, you're creating information, but not using to do things. So that's where digital twin comes in. This is where data analytics comes in from a value perspective, and that's why it's one of the top 10 strategies when Gartner talks about, when ARC talks about where industry is moving. Another study which analysts talk about is by 2021, majority or 50% of your industry would be incorporating digital twins, right? And they will be looking at 10% of their operational efficiency coming from that. So that's something which key, and in this session, we talk about how do I create a digital twin. Now, when we talk about digital twin, each of us have a different definition of a digital twin. We may be looking at a process or a simulation digital twin and say, that's where I can get value across. Some of us can be looking at just the operational aspect of it and say, I'll create a performance twin. But when Bentley talks about it, it's a digital twin which is evergreen, which could be used across the life cycle of facility, just not from a front-end engineering or project delivery or only through operations and maintenance or construction. It's about how do I create a digital twin which can be leveraged across life cycle. So while in this session, we would be focusing and talking more about how do I create a digital twin, but let's pause for a minute and talk about what's the challenge which I have today. We want to go to the journey creating digital twin, but what stops us? What are the various hindrances we have in our industry, in information what we have, which limits, I won't say it stops it, it creates hindrances in that journey as such. We talk about convergence of IT, OT, right? We saw case studies, we talked about them yesterday. There's another aspect of convergence, which is integrating IT, OT, and ET, ET being engineering technology. How do I leverage the information which is generated during my project delivery phase? How can I reuse that information when it comes to operations? And that's where digital model comes in. Now, one of the challenges which we face is when we start talking about in a digital twin, and depending on what scenario you are, if you're on a greenfield project, your scenarios are different. Your situations are different. When you're working on as-built and as-operated, a brownfield project, you'll have a different scenario. So ensuring that your digital engineering models, they could be 1D, 2D, or 3D, uh, do they really define your real representation of your facility? Does your documentation really says what's actually happening in your plant? What's in your plant? Uh, so I typically use two terms, and I don't really interchange them, one being as-built documentation and as-operated documentation. When I say as-built documentation, what it means for me is when my EPC hands over my plant to me, it typically gives you an as-built documentation. It will be incorporated with SCRs or some changes which have happened. But as I run my facility, I'm doing some minor or major MOCs, some changes to my facilities. Am I actually bringing those changes back to my document? If not, my documentation is not as operated document. It's only an as-built document, and that's not the true representation. Dow Chemical, when they basically do their internal study, they said any change which they did to their facility, it takes approximately 30 days to bring those changes back to their documentation. So that's not something a live system back. So you do a change, and then you go through a process of doing some changes back into documentation, but that too is not something which will give you a real state of your facility as we talk about. And again, your information is in silos, right? It's multiple systems. Whether we talk IT, whether we talk OT systems, or even engineering technology systems too, your information is in multiple sources. And the biggest challenge which comes is how do I aggregate that information? How do I bring those information into a common framework which could make sense out of it, which is actually changing my dark data to actually enlighten, which I can use for my decision making. And that's a skills, right? Because if you look at from your perspective, your engineering technology will talk about tags. They'll call about from a tag number perspective. When you go to CMMS or SAP, they talk about FLOCs. And none of your organization will have the same number for FLOC and SAP. You will have some appended elements to that. How do I correlate them back together? Similarly, when you go to your APM solutions, when you go to your Meridians or asset performance management from Bentley, your naming convention will again change back. How do I correlate and transform that information together? That's one of the challenges which we all face back. Making sure our information is open, right? We talked about interoperability as a key. I think it's very important it should be interoperable. Your system should be interoperable. Integration is good, but interoperability is better, right? There's a difference between having integration between different applications, but how do we ensure they are interoperable? So that's important. And then once you can able to integrate these information together, how do I visualize that information? And visualization for me could be a 3D visualization, maybe a 3D model which can become as a starting point to look for information, or could be a dashboard to look for information, and we'll talk about them as we move forward. So what's the answer, right? Digital twin. And Bentley, you heard Anne-Marie talk about a definition of digital twin. I won't go into details, but something which is important is a digital twin should be continuously updated. It's not a one-time exercise. It's not about I go into my facility, create a digital twin, and I'm happy I have a tick mark. It has to be continuously surveyed. It needs to be continuously updated as we create information. It's more about creating a evergreen digital twin, just not a definition of a digital twin that way. So how does Bentley helps you out? And this is where we will go to the technical part of that in terms of how do I create a digital twin for process industry. So PlantSight is a solution which helps you in the journey of creating a digital twin. And on a very high level, a digital twin creation can be split into two major activities. One being capturing the information, which means how do I aggregate information from various sources back? And I will say various sources, it could be an IT, OT, or an ET serve. How do I transform that information together? And more importantly, then how do I visualize and how do I provide it to various personas and stakeholders in my organization to consume that information? So these are the three aspects. How do I capture, aggregate information, transform, and then visualize and provide various use cases for my various personas in my company to start using it. And we'll talk through that journey as we go forward. That's on a very high level in terms of how you could create a digital twin. It starts with capturing an existing site conditions. What's exactly, it's more of an as-operated state. What is existing in facility. And then leverage what you have today in your tools. Whether you have 3D models, whether P and IDs, how do I aggregate those information together? And then use these for various sources, and that includes information from your DCS, information from your IT, OT systems, to fill and create a digital twin. And then use that digital twin during your life cycle processes across operations and maintenance for asset performance, for reliability. So that's a high level view of that. And we'll go into details and talk through how can we do that back. And it starts with aggregation of data, right? And when we talk about aggregation, there are various sources of information which we have today. We can have schematic. Typically, we use terms like 1D, 2D, and 3D. 1D being my structured data, line list, equipment list, information coming from DCS. My 2D informations being P and ID, instrumentation diagrams, loop wiring diagrams, SLDs. How do I aggregate information from there? And then engineering models, which means how do I bring information from my 3D models and aggregate that with sensors and reality models. So each of our organizations, when you think about this slide, and you would be ticking up few pieces. I have these information and I may have not these information. So we have two cases. One, we have some baseline to start with. My EPC was good enough to provide me with some digital information. Maybe 3D models, maybe 2D drawings, maybe 1D data. So we'll talk about both scenarios. How do I do that? So let's talk about if I had data and let's say we have some spreadsheets, some databases which have been provided. Plant site allows you to import that information back into system. So if my vendor, if I'm talking from an evergreen greenfield project, if my EPC is providing me in a predefined format, well and good if it's a standard format like CFOS, for a handover, I can directly start importing that information into my system, right? It provides with a tool, it provides you with a template, industry standard template. You can ask your engineering contractors to provide you information in those formats, or it could be a database dump which you can translate that back. And then when we talk about 2D and we talk about intelligent sources like intelligent P and IDs, and this is where Bentley Open Plant, Siemens Comos P and ID, or Hexagon Smart Plant P and ID comes in, or Aviva diagram, we can start taking information from them. We can start leveraging information from them to create digital twins. Plant site allows you to basically, we have created those translators or bridges which can start bringing information from them. And this can happen on your progressive handover also. So it's not a one-time dump you're aggregating. It can start with a 30%, a 60%, and 90% of data handover. If it's a greenfield project, we can bring information into our twin, aggregate information, and we'll talk about them in a minute. And same goes with my 3D models. I can start taking information from Open Plant, Aviva, E3D, PDMS, Aviva Marine, or Intergraph Smart Plant or PDS. So what happens if I'm on a brownfield project? What happens if I am not sure what I have as a data is consistent? What do I do in those scenarios? Anne-Marie showed this yesterday, where we talked about how I can use high-resolution images, drones, DSLRs, to capture images of your facilities back and create a digital twin or an engineering model which can aggregate information from these sources back. How it works is you start taking images of your facilities. It could be a photogrammetry, you could use drones, you could use DSLRs, or even your mobile phones to take images. Those yellow boxes which you see on that image are various places from where we are taking pictures for this asset. Okay? You'll see multiple overlaps, which allows you to capture your facility completely. And then we have added the artificial intelligence and machine learning on top of it. What it means is now that I have a reality model, I train my system to identify objects and classify them correctly. So I can, for example, what you see on a screen is I'm defining a volume and saying this is a butterfly wall. So I'm defining it's an asset class. It's a pump, it's a valve, it's a control valve, it's a pressure indicator, and I train the system to do that. Once that's done, and once I train and use machine learning to train my system, then the system automatically goes into the model, starts reading and getting information from that. Now it understands I am a valve, okay? It's understand I'm an equipment, but what is my tag number? What's my functional location? So there we leverage your nameplates, your tags which have been embedded on your equipment. So extract that information and define an asset object to it. So now we know what object it is, we know what class it is, and that information is then tied back into a digital twin to link to information coming from various sources. Here's an example of that classification happened. So I'm on a reality model. I can look at a butterfly valve and the object selects everything which you see is in, it shows me in pink, yes? So that's something on pink shade is all the butterfly valve which system automatically scans and starts identifying it back. So once, now I have my digital twin information, I have information extracted from these silos, then comes a point of aggregating this information. So I can start with my plant breakdown structure. If it's a brownfield project, I can go to my CMMS systems, I can go to my SAPs to bring that plant hierarchy. So I have a ready-made hierarchy which I can start using in, and then start aggregating information from various sources back. So for example, if I'm getting data from a P&ID and a 2D information from a vendor data sheet, it will be able to match and compare information. If there's some data inconsistency, it will highlight, it will generate reports, which I can use for decision making in terms of what information is correct, which becomes a master source and which to be brought into the system. So now at a point, now we have created a baseline of a digital twin. Let's talk about the various use cases, how I can use that digital twin. It starts with a design review, environment which allows you to review your facility, right? So what you see on the screen right now is a hybrid model. So it's a combination of a 3D model coming from a Bentley, a Viva, or an Hexagon technology, and a reality model which we captured using photogrammetry or drones back. They're intelligent in the sense of I can look at an object, because I've created a digital twin, because I've aggregated information, I can see all my operating conditions. I can go and start looking at information coming from my sensors directly on this model. And I'll show an example of that as we move forward. Now, I can use it for my OTS, right? Immersive training simulators. I can use the same model for my operators training. I can use it for various scenarios, SOP trainings for my colleagues. I can use it for familiarization training. I can use it for HSC training for my employees. I can use it for a collaborative training in terms of how to basically operate and work on the plants. So that digital twin can be leveraged for my training simulators or training of my employees. We talked about AR and VR. The same information, the same twin can be used for my AR and VR Google lenses, HoloLenses around it to query information. Help you to train your colleagues around that. And more importantly, because you are running a lot of MOCs in your plant, you'll be able to visualize what has changed in your plant over 2 time periods or 2 milestones. So I could basically query 2 of the MOCs which have happened and see what has changed, whether it was a new addition, a change in the property, a change in the characteristics, or if I added a new line or a process line, in this case, a new bypass pump assembly was added, I could see what happened on those MOC changes. So it's not just about showing you the final status as operated status, it can also help you to go back and look at what has changed, what were the drivers for this change, which MOC was resulting in that change. Look at who approved it back. So it's tying your IT, OT systems all together and providing you with a visualization layer to look at that information more graphically than just a textual report to look for that. Some more cases, as we talk from an operations perspective, how do I leverage IT, OT, and ET convergence? How can I use it for my reliability strategies? How can I use it from an operational perspective? So here's an example of a visualization across leveraging a digital twin. So what you see on the screen is a facility, a company, think about an organization which has multiple has a fleet of various process plants running back. The dashboards allow you to look at a high-level view. I can drill down into a particular facility. I can start looking at a process view of information. This is, again, I can start getting data directly from DCS. So this picture here is showing data directly coming from DCS here. I could look at informations. If you see, there's some red blocks at some equipment. So it's showing that some of the pumps and compressors are showing alarms. And now I can start drilling down into that information. So my interest is to look at this compressor C0218. So I want to see what's actually happening with that compressor because there's a red flag, there's an alarm shown to me as in the dashboard. So when I click on that compressor, now I will have a holistic view about this information. So again, not at the plant level, I'm at that equipment level, and I'm getting all my sensor information. I'm getting information from all my devices to tell me what's actually happening with that compressor. So I'm bringing sensor information. I can look at it from an engineering view also. So what are the related documents? What documents I have for that compressor? I could see what are the various failure modes defined for that compressor, which means how can this compressor fail? So I will be able to understand what are the various hypothetical events. I also can go and start understanding what's the inventory for that compressor, what parts do I have. Because it's an equipment, I have a digital twin, a visual representation of it, I can actually start slicing that compressor to see what are the various parts. How is it assembled? So I can explode the whole compressor to see various components around it. And then I can also actually go into a maintenance view of that compressor back to really see what needs to be done, what needs to be actually defined as an action item, what my operators have to do with that facility back. So here, you are actually looking at that same compressor and looking at various work orders which have been generated. So here we are leveraging your IT systems, the APM solution, the CMM solution there, and not just what are the current work orders, but also what have been closed work orders around it. And again, on your right, my right, which is your left, is a graphical view or representation of the same asset model. So now I'm looking at this, all this information in a visual format rather than a dashboard back. So now I can start looking at the various operational status. So think about it, all our users want some dynamic queries to understand the status of it, and we rely on dashboards to do it. Now with this visual representation, the users can dynamically create those queries. Say, I'm looking for various items or maybe all pumps which are raising my alarms. And it will start flashing like it's doing in the model that these are the two pumps which are flashing and generating an alarm right now. And then I can use this as my initial starting point to start inquiring about the information. So I select a pump here, and then I'll be able to understand all the engineering information. I can look at all the hypothetical events around it. I'll be able to look at in terms of creating work orders directly from the same platform. So right now what you're seeing is I'm looking at all the related documents for this pump. So I'll be able to see my PIN IDs, I'll be able to see the data sheets linked to it, any SOP which is defined for this pump. All this information would be available on my fingertips directly. I'll be able to see any attachments like anything which my operator, while he was on the round, captured for that facility. And in this case, it could be a simple picture where how the pump looks on my site. If there was some bleeding, there was a puddle created because of some leak, he can capture that image, bring it back into the system here. And then I can start looking at various failure modes. How can this pump, how can this compressor fail? So that whole hypothetical events, all the failure FEMA models are part of that. Now I can look at my current status, what's happening. So it shares here that there are two high alarms which are raised. And then I can start acknowledging those alarms directly here. So I'm not going into my CMMS system to create work tasks. I can directly be on the same one interface which integrates information from all sources, and I can start generating work orders directly. So I can define whether I want to create a new work task, or I could use the same operator round which is planned and ask an operator to look at the same pump in the same trip. So I can decide those information, create my a working task which can go to the CMS system directly. And more importantly, it's using all your defined user access controls. So it's honoring all the access controls which you have defined into your system directly from here. The more what it does is, it allows you to shift from one view to another. So right now what you were seeing was a 3D model as a view. So I can look at the same information in a process view also. So I can directly look at a paint ID, it hotspots the paint ID, it starts flashing in the paint ID also, that there's an alarm raised to it, because what we are doing here is creating a digital twin, which is converging information from all sources. And that's the value which it brings back here. Just not from a 2D or a 3D schematics. If I had a reality model, a model captured using drones, captured using a context capture, it could use that as also a base to start giving information and reporting that. So another 3 minutes left for me. So in terms of the benefits from a digital twins perspective, we all understand digital twins helps you in terms of your operational excellence, right? It helps you to ensure your data quality and security is maintained back. Like Institute of Configuration Management said, right? There was a report where they said, if your information integrity drops by 8%, if you're not sure of your information by 8%, your employee efficiency drops by 50%. So because you're not sure what data you have, people go back and try to vet it by multiple sources. So what digital twin provides you with an capability is, how do I improve my information? How do I ensure that the right information is available to the right people at the right time? It helps you in faster operation readiness. It helps you in improving your, reducing your cost. And with plant side, what we allow is, we allow you to enlighten your information which is today stored in your silos, as we call it dark data. It may be that somebody is leveraging that information, but that's only for a particular set of people. How do we make it available across the organization? How do I ensure people are able to leverage that information to make and bring value to it? Like one of our AEP users talks about who is using plant site is, today, my designer who is designing a pump does not really understand the value in terms of how that pump is performing in a real state, right? Because he's designing in silo, the equipment goes into operations, and he does not know how it's behaving in the current scenarios. With plant side, my designer also gets that leverage. He can directly go into a system and look at how my equipment is performing. What do I do to make it better when I modify and update the plant spec? It helps you in increasing your reliability. It's helped you in from a maintenance perspective, and Anne-Marie talked about it. It helps you in faster collaboration, helps you in better decision making. And what it more importantly does, it provides you information on your fingertips. Whether you're using your handheld devices, whether you're using desktops, whether you're using mobiles, all this information is available to you on your fingertips back. That ends my time around talking about digital twin. We are providing more information on our booth. So at the break, if you don't want to catch budget, happy to join us and we can talk about plant site more. Thank you.